Anyone who's been in the 3D industry for a while will quickly realize that it's the little details in a scene that take the largest amount of time and work. And also you'll quickly discover that those little details could easily be created in a two-dimensional way. So to deal with that, what we did was created the feature called Perpixel Camera Map, which is basically a tool that allows us to go in, render an environment at really high resolution, send that rendering off to a paint package where an artist can go in and paint in all the fine little details, all those little bits and pieces that are so much more work to create in 3D, take that finished map, and then reproject it back onto geometry inside of the 3D environment. Now you have all that detail as a map on your geometry, and whenever you do final renderings, it'll look like it was all created in 3D. In this case, we're going to use a castle, which was created for the movie Kingdom and Twilight by Dreamscape Imagery. And in this shot, we have a pan down of a camera and an army of people coming running through the door. And this army was actually created with Character Studio bipeds. So to do this, what we're going to do is just set this up to show you how Perpixel camera mapping works. To start off with, we're just going to adjust some light settings and set some lights up in the scene. So here I've got a standard light. This is actually a photometric light. And by photometric, I mean it is actually an accurate light that has accurate settings to the real world. So in this case, for instance, I can set up what type of distribution this light has. Typically it's usually set to isotropic, which is standard for lights in most 3D packages. But where we get an advantage is we can actually go in and pick web. So with a web setting, we're actually using what's called an industry IES file. And this is a lighting standard file that defines the spread of light from a point. So it actually will define how much power light has in any given direction from that light source. So here you can see I've got an IES file which has been applied. And you can see down here now the display of that light is actually showing how the light will fall off. What we're getting is a large canopy of light projecting out of the bottom and a smaller canopy projecting out of the top. So you can imagine if this light actually existed in the world, there's probably some sort of holder wrapped around the center which blocks the light from going out from the edges. Beauty of this is these lighting files are free to find on the web. In this case I got this lighting file from Urco. We're just going to use a standard isotropic in this particular case, but I highly recommend exploring using the IES files as they do create a dramatic amount of realism in things like architectural visualizations or any sort of environment. So in this case we've got our light. What we want to do is just spread it around the scene. We've got some point helper objects which are set around the scene as possible light locations. So to do that we're going to use another new tool we have which is called Clone and Align. And right now my light source is picked as my initial object, and now I just pick the dummy objects in my scene as my distribution, and it immediately goes and puts all my lights on those objects. I can then adjust offsets for orientation and position. So with those applied, I can now go in and prepare to render. So I'm just going to go to my rendering dialog, and first thing I'm going to do is change the render. I want to use the mental ray renderer for this, so I'm just going to pick mental ray, say OK. Now the beauty is in 3ds Max 7 we now allow mental ray to use all of our photometric lights and settings. So you now get these photometrically accurate lights in a mental ray render. And on top of that we also added in the ability to use mental ray with the render to texture system. So you can use render to texture to render out normal maps and texture maps for objects using mental ray. So in this case let's just jump into indirect illumination. We're going to turn on global illumination, and then we're also going to turn on final gather. And I can go in and I'm just going to adjust to some lower settings for now for testing, and yeah, we'll leave that there, and then I can just hit render. Now as it's beginning to calculate the rendering, you can see it's pulling in all the objects. It's now going to start to calculate all our global illumination and all of our final gathering. Now obviously this can take a very long time depending on the size of your scene, the number of polygons in your environment, lights, how you're using global illumination. So you'd really like to avoid doing this for every single frame of rendering if you can. So in this case we're going to let this render, and I'll just jump on to the next shot. So here we have the final image that came out of that mental ray render, and we're going to use this as our projection image. Now we could project this image straight back onto the original geometry we rendered it from. In fact, this is probably one of the more common methodologies. Just project it back on with the new painted details on that map. However, what we want to do is actually save some time and speed up a few other parts of the process. So what we've done is created a much lower res version of this castle. As you can see, in this particular scene, the castle is extremely high res with lots of geometric detail. So here we have the low res version of that geometry. As you can see, extremely low res. And what we're going to do now is start to do the projection. So first thing I want you to notice is we have a couple different camera views in here. One of those is the 3D tracked camera. So this is a camera motion that was actually tracked off the original backplate that this will be put into. And the other camera is the projection camera, which is the same camera we used in the other scene to do our rendering. So now I'm just going to go into my materials editor, pick a material. We're going to add a new diffuse color choice, in this case a camera map per pixel. Then I'm going to go in and say, what camera do I want to project from? Well, let's project from the projection cam. So we just pick that. And then what texture am I going to use? Well, we're going to use a bitmap. And in this particular case, the bitmap is going to be our projection render. And so I just drop that in there. And you'll also notice that we have a number of other choices in here. We have a Z buffer mask, a normal mask, and an angle threshold. What this allows me to do is actually project textures from multiple different angles on the environment and have them all blend together using masks. On top of that, I have an angle threshold which says once the polygons you're projecting onto get more than a certain number of degrees away from the camera, stop putting texture on them. So the benefit here is it means that with a 9-degree threshold, no faces facing the opposite way from the camera will get any texture on them. So once we've got that done, I just drag and drop it onto my scene, lay it in there like so, and if I do a rendering now, you can actually see that the texture is now on the environment. But the beauty of this is that I can actually go into my other camera view, my 3D tracked camera, and so there's my motion. Let's just take it to somewhere right about there. And now I'm going to use the scanline renderer because of its speed. Since the global illumination has already been calculated into the map I'm projecting, I don't have to recalculate that. So I'm just going to use the scanline renderer, and what we're going to do is just add in some motion blur. So let's just apply that. And I've made it pretty heavy so you can see it. I just want you to see how fast this will now calculate. So let's just go through here and say we'll just render this range for now. So you can see frame at a time, quickly cruising through here with motion blur. So this is the benefit of using this technique. Because I've projected onto very low res geometry, I've got all the benefit that I got from Mental Ray's global illumination, but now I'm getting it very, very quickly rendered in the scanline renderer on low res geometry. But it looks exactly like the original geometry we had. Now just to give you again one last example of how this can look, I'm just going to go into a perspective view and spin around this a little bit. Because what I want you to notice is what this looks like when you're off angle. So we're just going to go back in here and just render a signal. And what I want you to notice is see how the texture breaks. This is because of that 90-degree angle threshold. So what you could now do is actually go back to the original scene, build cameras at different areas, and render those images, and then match them together using the masking tool inside of the Perpixel camera map. Ultimately, the thing to remember about this feature is it allows an entirely new workflow. You go in, you can create your 3D geometry to whatever detail level you're capable of, render that off, and then paint on the rendered image in 2D to add in all the extra details like cobwebs, extra bricks, colored lighting, things like that. Stuff that can be very annoying and tedious in 3D. Take that image, reproject it back onto your high-res geometry, and you're ready to go. Now this feature has been substantially production tested. One of the studios we worked with actually developing this tool, The Orphanage, has used this in a number of feature films, including Hellboy and Sky Captain in the World of Tomorrow.